Okay, in this final video of basic concepts, we're going to describe a few specific basic circuit elements. So if you recall in the last video, our element was described as this two-terminal element that has a voltage potential across it and a current going through it. So this element is in general going to describe a mathematical relationship between V and I for regardless of the type of element it is. So the most basic of these elements are those that fix one of these parameters, either fixing V and fixing I, independent of one another. Okay, so firstly, an ideal voltage source is defined as an element that maintains a particular voltage across it regardless of the current going through it. Okay, so it maintains a particular voltage regardless of the current. Likewise, an ideal current source maintains a particular current regardless of the voltage across it. You've all been exposed to some of these already, so ideal voltage source being a little bit easier to conceptualize, I think. Batteries are examples of voltage sources. They maintain a particular voltage, at least you want it to, regardless of the amount of current that you're drawing out of that battery. Otherwise, it wouldn't be a good battery or a voltage source. So when we draw these elements on a page, we use symbols to denote the types of elements, thereby describing, or at least alluding to, the kind of behavior or the model that describes the mathematical relationship between the voltage and the current of that element. But the most basic of elements are these ideal sources. So I'm going to create a little matrix of sources. First, we'll talk about the voltage sources. So again, these are sources that provide a fixed voltage regardless of the current going through them. So all sources are described with one of two symbols, either a circle or a diamond. Okay, it's shown there on the bottom. What distinguishes the difference between voltage and current sources is that voltage sources have an indication of the polarity inside the circle or the diamond. All of these are voltage sources. They're really treated the same way, they're just slightly different ways to draw it. You might see a voltage source with a little squiggle in it, maybe not. If you do, it implies that it's a function of time, so you would see a script V denoting the function of the voltage. If it does not, it implies that it is constant, so we would see a capital Vs. When you see the script, it implies this is something called AC, or alternating current. If it is constant, we call that DC, for direct current. But we still treat them the same way, they're just voltage sources. If you see the diamond symbol, it's still, with the polarities inside it, it's still a voltage source, but it means that the voltage provided by that source is actually a function of some other parameter. For example, maybe it's a function of the value of Vx, which would be present somewhere else in your circuit. It could be a voltage source Vs that's a function of a current, for example, somewhere present in your circuit. So this would be called a voltage controlled, and this would be called a current controlled voltage source. Likewise, on the current side, we have the analogous situation. You might have a current source that is AC, script generating a current IS. We know it's a current source because we draw an arrow inside the circle denoting the direction of the current flow. It may be capital IS for DC. And of course, you might have a dependent current source. It's still a diamond, just with an arrow inside it, where the value might depend on another parameter inside your circuit, for example, IX, or the value might depend on a voltage Vx. Okay. So this would be called a current-controlled and voltage-controlled current sources. So this top row is what we classify as our independent sources, and the bottom row is what we classify as dependent sources. And then finally, note that these sources are also called active elements as opposed to the passive element, which is where I describe the passive sign convention. So whereas an active element is capable of supplying energy, note that a voltage or a current source maintains a fixed value regardless of if it's a voltage source, regardless of the current flowing through it, and if it's a current source, regardless of the voltage across it. So the power of a voltage or current source can be positive or negative. Okay. Passive elements only can have positive power because they're always absorbing. In general, there are certain types of passive elements that can supply for a fixed amount of time, but active elements is a specific definition that implies that we can supply energy. I'm going to put the caveat for infinite time, at least large enough time such that our circuit doesn't care. Okay, so for long amounts of time. Okay, so that concludes our modules on basic elements, basic concepts, from Chapter 1 of the textbook. Stay tuned for the next module, which will be a combination of Chapters 2 and 6.